So just like before, figuring this out, I think we did an example like this towards the end Tuesday night. It's figuring out how to divide this up. For area, I'm going to divide it like this, here, 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 and here. And the only reason I'm going inside the yellow area is because that makes each of those a complete quarter circle. So now what I have is the leftover pieces I have are 4 rectangles. These two are both the same. They're 40 feet by 10 feet. So that makes 400 square feet. And there are 2 of them. You know, one here and one over here. Up here, I'm going to label those number 2s. Those are 80 feet by 10 feet. Making each of those 800 square feet. And of course, there are 2 of those. So far we've got that total of 2,400 square feet if we add those up. We still need to make these corner pieces work. In fact, I'm going to do that in a different color so I can pull it out of there. So if I pull those out of there, what I'm going to get is this. This would be that corner piece there. Take out this corner piece and put it in there. Taking out this corner piece, it's going to fit there. I get that complete ring. And we did something similar to this. It was 2 half circles that made the ring last time. Now we're using the 4 quarter circles. We know that the full, actually this time it's easier to know the radius than is the diameter. What is the radius of this? Well, if we take 40 feet out of the middle here of an 80-foot total from edge to edge, that leaves 40 feet, right? So that'd be 20 feet on each side. That would add up to my total 80. So the radius here is 20 feet. So I'm going to find the area of the large circle, which is going to be pi times 20 squared. Remember, area of a circle is pi times radius squared. Pi times 20 squared is going to be 1,256 square feet. Bless you. What is the radius then of the small circle? Well, this is 10 feet thick. It's going to be 10 feet thick here too, right? So what's left over there? Say 10 feet. 10 feet. Good job. 20 is our radius, minus 10 leaves us with 10. So that small circle has a radius of 10. Its area is pi times 10 squared, or 314 square feet. We subtract that to get what's left over, which is going to be the area of that ring. That's going to be 942 square feet. That's going to go up here. So we add all those up to get our total area. It's going to be what, 3,342 square feet if I add those all up? Is that correct? Okay. Perimeter around the outside. The perimeter is actually a lot simpler than it looks. For perimeter, we have 80 here, 80 here, 40 here, 40 here. Let's add those all up first. 80 plus 80 plus 40 plus 40. And all we have left to add to it are these arcs here. Well, those 4 arcs make the outer edge of this circle. The circumference is pi times diameter. The diameter, if the radius is 20, the diameter would be 40. Pi times 40 is 125.6 feet. So plus 125.6 feet. So that makes, if I add that all up, 365.6, I believe, feet of perimeter. Is that correct? Any questions? How do you think you could do that on your own if you had to now? I see like one hand twitching, but nobody raising their hand. Okay, well, hopefully over the next couple classes we get a little bit better at those. That is kind of about one of the toughest problems I would ever expect you to do, something like that, just so you know. When we left last class, I gave you an extra credit question. Anybody get an answer for it they want to try? No? I gave you a hint, and the hint was to make lists and look for patterns. I refused to tell you how many cows they had. So the number of cows could have been 1, 2, 3, on up to however many cows exist in the world, right? 320 will be far enough for us to go for our pattern here. The key was I told you that no matter how many cows they had, the amount of money they got per cow was equal to the number of cows. So the amount of money they had was going to be the number of cows they had squared, basically. So if they had one cow, they got $1 per cow, which would have came out to be $1. If they had 2 cows, they got $2 per cow, which made them $4. 3 cows would have been $3 per cow for $9. 4 cows would have been $4 per cow for $16. And let's continue that pattern. Come on. So 320 cows would have been $320 per cow for $102,000. Of course, the next step was they bought sheep, right? What do we know about the sheep? What's that? It was an odd number, yes. But we also know that sheep are $10 each. So if they only had 1 cow, how many sheep could they buy? None. They didn't have $10. If they had 4 cows, they would have got $16. That's the lowest amount they could have had and bought any sheep would have been 4 cows. So let's look at how many sheep they bought. So if they had 320 cows, they would have had $102,000. They could have got 10,240 sheep. That's a lot of mutton. The key to finding the value of the dog is trying to figure out what the goat cost. What do we know about what the goat cost? Had to be less than $10, and it was everything that they had left over. So if they only had 1 cow, they would have got $1. They couldn't have bought any sheep. They would have had $1 left over to buy the goat. If they had 4 cows, they would have got $16. They'd have bought 1 sheep and had $6 left over for the goat. If they had 5 cows, they would have got $25. They'd have bought 2 sheep and had $5 left over for the goat. If they had 320 cows, they would have got the 10,240 sheep. They would have had nothing left over for the goat. So now here is the key. We knew they had an odd number of sheep. So we go down the list. This is an odd number of sheep. This is an odd number of sheep. Where's the next time we see an odd number of sheep? Right there? Right there? There's one. There's one. Is anybody noticing the pattern yet? Yeah. Every one that gives us an odd number of sheep, there's $6 left over for the goat. It's actually a little quirk about numbers. These numbers here are all perfect squares. A perfect square means it's a number squared. If they had an odd number of sheep, since the sheep cost $10, that means that the digit in the tens digit, let's just pick one of these out. Like for the 36, it was 1156. Since that is a perfect square, any perfect square that has an odd number in the tens digit always has a 6 in the ones. It's just the way it's worked out. So we know that if they had an odd number of sheep, the goat had to cost $6. So if the goat cost $6, the value of the dog was $4. A couple of people actually did email me and say $4, but they could not explain it. I've been using that problem for about 12 years now, and I've had only about 4 or 5 people give me the correct answer. Did anybody find it online? Try to look it up on the internet and find it? You thought about it? I don't know if that one's out there or not yet, or not. Chickens? Okay. So, for extra credit this semester, we had the white bear and the $4 dog. Do you want me to give you an easier one to try for next class? Okay. So, for next class, we'll have you try this one. I am going to let x equal 1. And so far, what we know about algebra and equations, we can multiply both sides of the equation by the same thing and it won't change the equation, right? So I'm going to multiply both sides of this equation by x. What's x times x? X squared, good. What's 1 times x? X, good. Now another thing I can do with an equation is I can subtract the same number from both sides. I'm going to subtract 1. X squared minus 1 is x squared minus 1. X minus 1 is x minus 1. Now we haven't done a lot of factoring, but we did a little bit. X squared minus 1 is x plus 1 times x minus 1. I'll prove that to you. If I do negative 1 times positive 1, that's negative 1. Negative 1 times x is negative 1x. X times 1 is positive 1x. X times x is x squared. We've got negative 1, negative 1x and positive 1x cancel out, x squared. So x squared really is x plus 1 times x minus 1. That equals x minus 1. Now here's what I'm going to do. I'm going to divide both sides of the equation by the same thing. That's legal as well, right? I'm going to divide by x minus 1. What's anything divided by itself? 1. Right? 7 divided by 7 is 1. X divided by x is 1. X minus 1 divided by x minus 1 is 1. I'm going to divide by x minus 1 over here as well. We can cancel out factors. X minus 1 and x minus 1 cancel out. We're left with x plus 1. Make sense? Well, I can subtract the same number from both sides, right? So subtract 1, that's gone. X equals, what's 1 minus 1? 0. X equals 0. What did I start off with, though? X equals 1. A property in math called the transitive property is if A equals B and B equals C, then C has to equal A. So if X equals 1, and at the same time x equals 0, then 1 must equal 0. So I just proved that 1 equals 0. Obviously, that's not true. There was a very, very fatal logical mistake in what I did here. So again, I started out with x equals 1, multiplied both sides by x to get x squared equals x. Then I subtracted 1 from both sides. Give me x squared minus 1 equals x minus 1. Then I split the x squared minus 1 into x plus 1 times x minus 1, which is true. I divided by x minus 1, cancels that out, gives me x plus 1. X minus 1 divided by x minus 1 is 1. Anything divided by itself is 1. Then I subtracted 1 to get 0. It looks like everything is good there, doesn't it? But it can't be. Because 1 cannot equal 0, otherwise our whole theory of numbers is out the window. So by next Tuesday, and I said if you want to email me the answer, the first person to email me the answer will get 10 bonus points for this one. Everybody after that will get 5. If you can figure out what's wrong with that. It's one of those that really, once you see it, it really sticks out. Okay, any questions on that before we go back into our material? Okay. So we were talking about volume and surface area. Let's have a little bit of a review. Of a box like this. And let's say that this is 24 inches by 16 inches by 15 inches. What is the first step in finding my volume? Always. Area of the base, right? Since this is a box, any side could be the base. But we choose to always use what? The bottom. So what is the area of that bottom? How do we find that area? 24 times 16. Good. Which will give us 384 inches squared. Now we use that for the volume. 384 inches squared, and what do we multiply it by? What's the only other dimension left up there? 15 inches. Think of it like this. We are taking this 24 by 16 sheet and we're stacking it on top of each other to make that height. How many times we have to stack it on top of each other is given by that 15 inches of height. So we got 384 times 15 gives us 5,760. And inches squared times inches is inches cubed. That is our volume. So any questions there? For surface area, first thing we need to find is the area of our base. Well, we already have it. 384 square inches. Do we need it again? We have another base on top. The top is the same size. So we have to add that in again. Do you guys remember what we called the area that was left around the outside here? It's called what? Lateral area. And to find the lateral area, we need to know two things. The first one we need to know is the perimeter of the base. So the perimeter of the base here is just the perimeter of that rectangle. So 24 inches plus 16 inches plus 24 inches plus 16 inches equals 80 inches. What we're saying is the distance around here is 80 inches. Because now if we took all these upright sides, those rectangles that connect the two bases, if we fold them all out like this is 16, 24, 16, 24, that total length is 80 inches. And the height of it is still the 15 inches here. So our lateral area is the perimeter of that base times the height. So it's 80 inches times the height of 15 inches, otherwise known as 1200. Inches times inches is inches squared. So that gets added in there to give us 1,968 inches squared is our total surface area. Any questions? In your notes, I want you to try to find for me quickly the volume and the surface area of this cylinder. I'll give you about 4 minutes or so. So for volume, we start out with the area of the base. Since the base is a circle, it's going to be pi times radius squared. Our radius is 8 inches. The 16 is the diameter, so we have to cut that in half to get the radius. So it's pi times 8 squared, which is what, 200.96 inches squared? Is that correct? Close enough. Our volume then is the area of that base, 200.96 square inches, times our height of 20 inches, which is 4,019.2 inches cubed. Is that correct? Anybody else get that? Anybody? So I'll go through the whole thing. 3.14, oops, clear out. 3.14 times 8 squared is 200.96 times 20 is 4,019.2. So any questions on either of those two steps for the volume? So that's really it for the volume. For surface area now, remember, we're going to add the bottom base here, which has an area of the 200.96. We're going to add the top base, which is also 200.96. And then we're going to have to add the lateral area, which we still need to find. To find the lateral area, we need the perimeter of the base, which is equal to the circumference of a circle. That's going to be pi times diameter. So pi times 16, 50.24 inches. Which then makes our lateral area, the perimeter of the base, times the height. So that is 50.24 inches times the height of 20 inches, which gives us 1,048 square inches. Bless you. Again. We add those all up. We get a total surface area of 1,449.92 square inches. 1,450 might be close enough. Does anybody come close to that one? Any questions on that one? Really the only trick, I mean, we have the base, so the bottom and the top from doing the volume. It's just finding the lateral area. And you just have to know that you find the perimeter of the base and multiply that by the height to get that lateral area, that lateral surface area, which is added to the two bases. Well, it's time to throw a little bit of a wrench at it. Let's say we have a pyramid. For volume of that pyramid, when we did areas of triangles, we found the area of the related rectangle and divided it by 2, didn't we? So for the volume of the pyramid, we're going to find the volume of the related box. And we're going to divide it. The question is, do we divide it by 2? Let's take a peek here. If I have a box, if I cut it in half, do I get a pyramid? I cut it there and there. Does that make a pyramid? No, what it makes is a wedge, isn't it? To turn it into a pyramid, I have to cut it again. Like this. Of course, what I removed there was not half of what was remaining, was it? Because I was just removing that, the really sharp part of the wedge up here. Well, to figure out exactly what fraction I just removed, we would have to go into calculus. We don't really want to go into calculus. We talked about it briefly when we did the area of circles, but we're not going to get any further into it. So you're going to have to trust me on this one. The volume of the pyramid is the volume of the related box divided by 3. Here's how I remember that. For a triangle, how many dimensions is a triangle? It's 2-dimensional, right? Length and width, it's flat. So for area, it's 2-dimensional. I divide by 2. For a pyramid, how many dimensions is it? 3. Length times width times height. So for volume, it's 3-dimensional. I divide by 3 from the related box. So over here, I am still going to find the area of a base. The area of my base here is 20 inches by 20 inches. That's 400 square inches. My volume then is going to be the area of that base, 400 square inches, times the height, which is 24 inches, but we have to remember to divide by 3. 400 times 24 is 9,600, divided by 3 is 3,200. Inches squared times inches is inches cubed, cubic inches. So the volume there is 3,200 cubic inches. So I'm going to pause. Any questions there? So the volume is the area of the base times the height divided by 3. In your notes, I want you to leave about half a page of space, because we're going to come back to that problem in just a second. Right now we're going to talk about cones. Find the volume of a cone. We're going to find the area of the base. Area of base is pi times radius squared. So for this one it'll be pi times, what's my radius? 8. Yep, so 8 squared, which is 200.96 feet squared. For my volume, what do you think I'm going to do? .96 feet squared times 15 feet, my height of 15, divided by 3. Just like with the pyramid. Notice the similarities here. Area of the base times the height divided by 3. Area of the base times the height divided by 3. Which will give us 1,004.8, I believe, cubic feet, or feet cubed. Well, let's go back up here to our pyramid. And let's talk for a minute about surface area. There are two big differences in surface area now for a pyramid as compared to the boxes that we did before. The first big difference is how many bases are there? 1. There's only the one on bottom. There isn't one on top anymore. So for surface area, you only have the area of the base in there once. So it's going to be the area of the base plus the lateral area. The second big difference is that the lateral area is, on all of our other shapes, the lateral area were rectangles, weren't they? Here the lateral area is triangles. So we're going to have to deal with triangles for lateral area. So that's going to come in just a second. There is we can call it a third difference, but it's really part of that second big difference. It's part of the lateral area. All the other shapes that we did, since the sides went straight up, the height was equal to the length of the side, the height of the side. Here, that's not true. These sides angle up, don't they? So the height of that triangle is not the height of our pyramid, because the triangle goes up at a slant, at a slope. So the height here is 24 inches. That's straight up the middle. What we need is this length, which is called the slant height, or just the slant. How do we find the slant? Well, right here, this is a right triangle. This side is 24 inches. What's this side down here? 10 inches, half of the 20, right? Assuming that this is a regular pyramid, so that the peak is right above the center of the base. It has to be half of the side of the base. So in a right triangle, how do we find the hypotenuse from the two legs? Perfect. A squared plus B squared equals C squared. So we have 10 squared plus 24 squared equals C squared. What is 10 squared? 100. What's 24 squared? 576, right? We add those to get 676 equals C squared. Square rooting gives us C equals 26. Does that look familiar? Hopefully. So back up here, this length is 26 inches. So our lateral area is now changed. The lateral area is still the perimeter of the base, but it's not times the height anymore, it's times the slant. And because it forms triangles instead of rectangles, it is divided by 2. So we still need to find the perimeter of the base. Each of the 4 sides is 20 inches, so that's going to make 80 inches is the perimeter of our base. So then the lateral area is the perimeter of the base, 80 inches, times that slant, which is 26 inches, divided by 2. So 1,040 square inches, if I'm thinking correctly. So that gets put over here for our lateral area. So we add our one base to our lateral area, the total surface area of 1,440 square inches. Any questions there? So down here for our cone, if you haven't noticed yet, there's a lot of similarities between the pyramid and the cone. For surface area, we've got to add the area of the base, which was the 200.96 square feet here. How many bases do we need? Just the one. And to that we're going to add the lateral area, which we're going to find right now. For lateral area, we need to know 2 things, and both of them have to be calculated. We need to know the slant. How do we find the slant here? That'd be a right angle. This is 8 feet here. This is 15 feet. So it's going to be what? Eight squared plus 15 squared equals that slant squared. 8 squared is 64. 15 squared is 225, which adds to make 289 equals our slant squared. Our next step would be to square root, gives us 17 feet. So the slant here is 17 feet. So we found the slant. What is the other piece of information we need to find our lateral area? The perimeter of the base, which in this case is a circumference of the circle, which is pi times diameter, which will be pi times 16, which is 50.24 feet. So lateral area is the perimeter of the base times the slant divided by 2, because just like the pyramids, it's triangular. So the perimeter of the base, 50.24 feet, times the slant of 17 feet divided by 2. Gives us 427.04 square feet of lateral area. So that adds up to give us 628 square feet total surface area. Any questions? Okay, it is time for our break, so let's go ahead and take our break. We'll come back at 4:31 and start up again.